are not continuous. That is these two cases here. And these two are continuous. I just want to tell you a brief thing about logic, which maybe you already know. Let's suppose you have a statement, P implies Q, and it's true. Okay? What is it? What other true thing does that imply? Say again. Good. Good job, man. Not Q. Oh, is he not? What do you say? Hold on a second. What order did you say it in? What order did you say it in? What order did you say it in? Not Q implies not P, right? Not Q implies not P. If this is true, then this one's true. We can't guarantee the truth of not P implies not Q. We can't guarantee that. Right? So in this case, we have this true statement over here. If a function is differentiable at a certain location, then it must be continuous. So now, what does that imply logically? That if it's not continuous, right? This is P, it's being differentiable. Q is being continuous. So not Q must imply not P. So, right, so if something is not continuous, which is these two cases here, I don't have to think about it at all. It's automatically not differentiable. But just because it is continuous, I cannot guarantee that it is differentiable. I don't know. Okay? So whenever something is differentiable, certainly continuous, and that implies when it's not continuous, it is not differentiable. But you see cases where it is continuous and yet not differentiable. So you have to be careful about the way you apply these things. All right? Baker? You with me though?
Yes.
All right. Snyder? You're lying, Snyder.
It's not continuous, it's not.
Good man, Snyder. What if it is continuous?
If the line goes, if it goes to vertical, then
Good man. All right. Guys got some brains out there. Good. Good deal. All right, you ready for the rules now? What? Ready for the rules? Say again? We're on 3.1 still. This is 3.1, all 3.1. 3.2 begins the rules. Are you ready to begin the rules? Chan says yeah. Don't argue with Chan. All right. Chan, you know any martial arts? Not really, you say? Lee? Martial arts at all? Caesar?
Nope. I don't know.
Lou? Any martial arts? Any martial arts? You guys are crushing my stereotypes. What are you doing?
Huh?
You watch wrestling? What? What'd you say? Oh, MMA? Okay. You learn anything from there? Yeah, I didn't think so.
Yeah,
I don't know if it's much of a learning experience, really.
not really.
If you're big and used to getting your face crushed, you might win. I think it's what MMA is tough people. Fine. 3-2. You can't bring me down. Rules for derivatives. How do you want it? Fast and furious or slow and easy?
Is there a middle?
There's not a middle. How do you like it? How do you like being romanced? How do you like it, Justin? Like fast? Like slow?
I still haven't even watched the new movie yet.
Can you just go slow?
Snyder, what'd you say? What'd you say?
He said he hasn't seen the Fast and Furious movie.
What's the Fast and Furious movie?
Fast.
They do math
It's
really
a
fast.
movie.
It's called Furious 7.
It's a race car movie.
Yeah.
Race car
street
movie?
racing.
Like Days of Thunder?
You're gonna have to get into this century if we're gonna understand it.
Remember the first
You know,
movie I
Paul
came out?
Walker,
Paul
Yeah.
Walker.
Yeah.
the guy who died.
A lot of people died. I don't know that defines it very. Doesn't
The
define
guy
this
from
guy
Brick-
very well, does
like
it?
Brick Mansions.
He did what?
He did Brick Mansions.
Rick
The
Mansions.
guy with the cool hair in the first one.
Cool. The first
You
one of
don't
what?
even know what the first one is.
Let's pull up a picture.
Paul Walker. Should I know him?
Should I know?
Yeah.
It was on the news.
It's not
Like,
I never really
Lee, do you know Paul
Do
Walker?
you want to look at this really quick right here?
You can show me. I don't know if it's gonna mean anything.
That Paul Walker.
I don't. Very not for anything.
I'm gonna withdraw from this class on that.
Walker. Guest
Can't.
starring in several television shows such as The Young and the Restless. That's pitiful. He did a soap opera. Crying out loud.
Disrespectful.
Whatever.
Surprised he
Let's
made it
get
out
to
of
the
that.
soap opera part. I mean, the movie part
Yes,
was more
he's
important.
known for the Fast and Furious movies.
He's known for the Fast and Furious movies. How many are there?
Like
7.
19.
Nothing. 19.
Yeah.
Nothing has ever been made 19 times and been good. No movie has had 18 sequels and been good. I'm sorry.
We surprised.
I would be. You're
The
right.
later one talked about Tokyo Drift was just like.
I actually like Tokyo.
I
Drift.
like Tokyo.
I like it too, but the plot in that is ridiculous.
I like what they tried to do with it. It was a nice spin-off, but
Well, can we go slow?
Too Fast and Furious is still the best one of all time. I'm gonna just put that out there.
Is that the second one? Because
Yes,
two.
it is.
That's so clever, isn't it?
And after that, which is the Fast and the Furious.
Uh,
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
yeah, that wouldn't be as catchy, I guess. All right. Rules. You have a constant function, and Corneo has requested slow and easy. So let's say you have a constant function c, right? It's any number you want. Any number you want at all. F of x is c.
2.
We're not going to pick a number though. All right. So it could be 2 though, for example. Let's say it was 2. We'll pick one. 2. 2. What does a constant function look like as a graph? Well, there's Fast and Furious for you. All right. It looks like a horizontal line. There is y equals 2, right? Horizontal line. What's the slope of a horizontal line?
0.
Very good. And it never changes, right? So we should anticipate that if f of x is a constant function, then f prime, the derivative now, must be 0. So any constant, when you take its derivative, is 0. I don't have to use a little bit definition for that. 0. Done.
Wait, can you say that again?
Yeah. Let's just do this real quick. You have a constant function like this, right? You said y equals 2.
Oh.
And what does the derivative find? The derivative finds the slope of functions.
Okay.
Okay?
Alright.
So, since you said slow and easy, let's find the slope of this function using the definition. And then we'll never resort to it again for this case. Limit as h approaches 0. Well, it's of f of x plus h minus f of x over h. So now, what's f of x plus h? Well, the function is constant. So it must be the value c, right? So the top is c minus what? F of x. What's f of x? It's always c. So it's c minus c above over h. What's c minus c?
0.
Correct.